For objective 5, we're going to solve something called a three-part or a compound inequality. Now the steps that we use to solve this are still the same 7 steps from solving equations. The only 2 changes are multiplying or dividing by a negative, change the direction of the inequality, okay, just like they did in a regular inequality. It'll change it in the compound inequality. And the other one is that compound inequalities have 3 sides. So if you remember back to the golden rule many sections ago, where we say what you do to one side you have to do to the other, because they have 3 sides, what you do to one side you have to do to the other 2 sides, as a way of explaining it. So when I solve these compound inequalities, my goal is still to get the variable by itself, and I still have to do that by removing whatever numbers and operations are surrounding it. But instead of just doing it here and then over here, I'm also going to need to do it over here. So I'm going to set up this equation by making 2 of those lines down the middle. My goal is to get z by itself, and it's this added 7 that's in the way. So if I subtract 7, that will give me z by itself. But if I subtract 7 from the middle term, I also have to subtract 7 from here, giving me a 2, and from here, giving me a negative 3. Now, since I was just subtracting 7, not multiplying or dividing by negative 7, all the inequalities are going to stay in the same direction. That's the algebraic answer. We're going to skip from here to the graphing answer, and then come back to how we write that in interval notation after we see what the picture looks like. So I'm going to start by putting my 0 on the line. And somewhere over here to the left is my negative 3, and somewhere over here to the right is the positive 2. So those are the points where change is going to happen. Now, and if I look at just the left side of it, it says z has to be things that are bigger than negative 3. So I know I'm shading in this direction. But z also has to be things that are smaller than 2. So that has me shading in this direction. So the only answers that are going to work are the ones that fall in this interval between the negative 3 and the positive 2. Because they were greater than or equal to, I'm going to use a pair of hard brackets to show that answer. And when I go to write it in interval notation, it's the negative 3 to 2 that I write as my answer. Looking at one more problem like this, I'll make 2 lines again to show the 3 sides of the equation, and my goal is still to get that x by itself. I have to peel off the plus 4 and the multiplied 3. So I'll subtract 4 from all 3 of my sides. That'll give me a negative 15 here, a 3x here, and a 3 there. And the inequality symbols did not change direction. They're still facing the same way. Then I'll divide each of these terms by 3. Since I'm dividing by a positive 3, I don't need to change the directions of my symbols. They're still going to be facing the same way. X is now by itself in the middle term. The right has become a 1, and this side has become a negative 5. So I go to graph this. I plot my 0. Negative 5 lies somewhere down here. positive 1 is somewhere up here. And once again, x needs to be values that are larger than negative 5. So I'm going to be shading this direction. But x also has to be values that are smaller than 1, which makes me shade this direction. When those two shaded areas meet in the middle, that shows the part of my graph that is the answer. And because these were less than, not less than or equal to symbols, I'm going to use parentheses, not brackets, on my number line. That makes my interval notation answer -5 to 1.